All right, we're on to 10.6, which is absolute values of products in open sentences. So basically this is the exact same thing that we were doing before, same pattern, and that's why I have it posted here again. But instead, if you look down here, you see instead of just us adding, we're going to also have to divide. But it's really not going to affect many things because once we set it up, it's the same thing we've always been doing. So hopefully you'll see that in just a second. Again, keep a reminder, again, this is the pattern that we're using. And again, the x represents whatever is supposed to be inside the absolute value. So it's not always just going to be the variable. So like if you see example number 1, our x would be 2p minus 3. So it's anything inside of the absolute value. We use, our signs, and this could also be used or equal to for either one. It doesn't really affect it. You just change it over here as well. And then whatever number you have here, you just, do the negative and the positive of both of the numbers. So again, this is a pattern that we're using. And hopefully you have it memorized by now. Okay, but we have our first example. So to solve, the absolute value of 2p minus 3 equals 7. Okay, so we know that this is an or situation right here, and we can split it up. Again, the reason why we're doing this is we can't solve with the absolute value signs. You see how we start with the absolute value signs and we make it so there's no absolute value signs anymore. That's what we're trying to do. We can't have those to solve it. So I'm going to basically rewrite it without the absolute values, which is using this pattern. So I have 2p minus 3 equals a negative 7. Okay, so I took my inside, I took my x, and it equals my negative number. Or I have 2p minus 3 equals a positive 7. And once I have that, I solve them separately, and we know how to solve it with this. So again, I'm going to add 3 to both sides. So I get 2p equals a negative 4 divided by 2. So p equals a negative 2. Then I add 3. I get 2p equals 10 divided by 2. And I get p equals 5. And it's an or statement, so this is my answers. We could also write it as a solution set and say negative 2 comma 5. I'm going to go ahead and graph it. I didn't put graph, but we'll graph it. So if I have it on here, I have a negative 2 and I have a 5. If you just have that point, it's just the dots. Just a dot there, dot there. Those are the only thing that's included, nothing else. So there you have that. Now we're going to actually do one with an inequality. This is a greater than 1, or greater than or equal to. So again, if you don't remember, if you look back up, we're going to be using this one right here, another or statement, okay? So x, or the inside, is less than the negative of it, or the inside is greater than the positive of it. So I'm going to take it. The inside is going to be my 10 minus 2k. And I'm going to say is less than or equal to the negative version of it. Again, if we look back up here, that's what it says up here. Or I'm going to say the inside, 10 minus 2k, is greater than or equal to the actual number of that. And then we're going to solve it. Again, nothing's different. Once we set this part up, nothing's different. We know how to do this. So minus 2k. Ooh. Let me just fix that. Negative 16 divided by a negative 2. Now I'm divided by a negative, so that means its k is now greater than or equal to 8. Okay, and then subtract 10. So I get negative 2k is greater than or equal to a negative 4 divided by a negative 2. Again, I'm dividing by a negative, so k is less than or equal to 2. It's an or statement, so this is my answer. Again, it doesn't say graph, but we're going to graph it. So, 2, 8. Close circle to the left, close circle to the right. Hopefully you're getting the hang of this. Make sure you have it memorized.